In this problem, we are finding the volume of the solid generated by rotating the region R through 360 degrees about the x-axis. First, we will divide region R into R1 and R2. R1 is the area under curve C, and R2 is the area under line L. Then we need to define the limits of each region. R1 starts from the intersection of curve C and the x-axis. Let us call this point A. Let point B be the intersection of the curve and the line, and point D be the point where the line crosses the x-axis. The equation of the curve is y squared equals x minus 1. On the x-axis, y equals 0, and we get x equals 1. Thus, the coordinates of A are 1, 0. The equation of line L is 2y plus x minus 4 equals 0. When y equals 0, x is 4. Thus, the coordinates of D are 4, 0. To find the value of B, we substitute x equals y squared plus 1 into the straight line equation. Simplifying, we get the quadratic equation, y squared plus 2y minus 3 equals 0, which can be factorized as y minus 1 times y plus 3. There are two possible values for y, 1 or negative 3. Since b is above the x-axis, we take the positive value for y. When y equals 1, substituting into x equals y squared plus 1 gives x equals 2. Thus, the coordinates of b are 2, 1. The volume generated by rotating R1 is calculated as pi times the integral from 1 to 2 of x minus 1 with respect to x. Integration gives x squared over 2 minus x. Substituting the limits x equals 2 and x equals 1, and solving the expression, we find the volume equals pi over 2. Rotating R2 about the x-axis will generate a cone. The formula for the volume of a cone is 1/3 pi r squared h, where the radius is the vertical distance from B to the x-axis, and the height is the horizontal distance between points B and D. The radius is 1 unit, and the height is 2 units. Solving the expression, the volume of the cone is 2 pi over 3. Adding these two volumes gives 7 pi over 6, which is the volume of the solid generated by rotating R through 360 degrees about the x-axis.